Hello guys, my name is Lazaro and today we're going to be doing a LeetCode problem. This problem is called letter tau possibilities. You have n taus where each tau has one letter, taus of I, printed on it. Return the number of possible non-empty sequences of letters you can make using the letters printed on those tiles. So pretty short description right here, but basically let's get right into the example 1 and see what's really asking from us. So we're given taus and it's a string of letters and they want us to figure out how many sequences we can make with these letters. So for example, we can have just A, just B. So that's right here, just A, just B. We can also have AA or AB. So that's right here, AA, AB. We can also have A, skip the second A, and then go to B for uh, another AB, but since we've already seen that one, we don't want to recount it. Now we can start working with the B. From the B we can build BA or BAA, so it's this one and this one. And then of course we can go from the first A, then to the B, and then back to the second A for ABA. And then the whole string itself is just AAB right here. So that's how it gets 8. Uh, and that's kind of what it's wanting from us. And instead of actually printing out or returning an array of these sequences, they want us to return how many sequences there are. Since there's 8, we just return 8. So this problem, I don't know if you guys have noticed, it's pretty much asking for a permutation of these taus characters. Now I'm saying permutation because the order does matter. So AB is not the same as BA. So there are two different sequences. So that's really our task here, to build a permutation with these characters and the frequencies of these characters. So it's from that hint right there, it is pretty straightforward. And you might also have noticed that it is a backtracking problem. Let me get to the drawing right here actually. It is a backtracking problem because let's say we initially start with the A. From there, we can go to the next A and then finally to the B. Then once we're done with this sequence, because we can no longer use any other characters, we're going to backtrack to the second A, and let's try changing that to a B, and now that's how we get ABA. But of course, since valence sequences are also just A or A or A, B, then every time we're calling our recursive function, we want to increment a count by 1 as well as calling it. So just by adding the A, we have, let's say our answer is 1. From this A, we're going to be adding another A. So now it's 2. From there, we're going to get a B. So that's 3. Then we can backtrack and we can do A, B. So that's 4. Then A, that's 5. Now we can backtrack once again to just B. That will be 6. Then BA, that'll be 7. And then BAA, that'll be 8. So I'll also write out the A right here and the AA. So we have our 1, 2, 3, 4, 5. This one we already counted, and so this one, I believe I'm missing. Yeah, I'm missing the B, A, just the B, 6, 7, and then AB, then 8. So I didn't write these down because I built upon them. So when I wrote out this A, I then wrote out the B, and then I wrote out the 8 right next to it. But we did see these sequences. So let's try to work on it a little bit more. Just in case, backtracking is a pretty confusing concept in itself. So let's not dive into the code just yet. Let's talk about it just 1 or 2 more minutes. So here in this sequence of tiles, we know that we have seen A, or we have a frequency of the character A, 2 of 2, a frequency of 2. And then the character B has a frequency of 1. So from here, what we want to do is that we can really iterate over these frequencies or over these keys because we really only want to look at the unique characters. Then while these characters has a frequency that's greater than 0, then we know that we can use them. So we can just set up a hash map in the beginning and do this. And then in our recursive function, let's first try A. And then we need to bring down this 2 to a 1. So when we call the recursive function, we know we can use A once and we can also use B once. So this is a very important step for this backtracking and recursive solution. Then of course, it's we called it and then it's probably to build out the A again. This is going to change to 0 and then it's going to attempt the B. This will be changed to 0. And every time we're dropping this down, we're incrementing that answer variable. But once the recursive function terminates, it's going to be rolling back, and we want to change the frequency back from 1 back to 2. So like I said, the backtracking problems are pretty confusing, so let's get into the code and see if we can make sense of it. The first thing, like I said, is we're going to want the frequencies of these letters inside of tiles. So let's just call this, create a hash map called char or char for standing for character frequency. Now let's iterate over all the characters in tiles. Let's get the current count of this character. And if it's not in the hash map, let's default to 0. Now let's update the hash map to make it equal count plus 1. Now let's build out our recursive function. We're going to be taking in that frequency. And if the frequency of every character inside of this hash map is 0, then we know that we cannot use any more letters and we are done. So one way of doing that is just by summing all of the values inside of this hash map. And if that summation is less than or equal to 0, it will most likely be equal to, then we can just return 0. Else, we do have some letters we could use in this hash map. So let's iterate over those letters by looking at the keys of this hash map. And just to make sure that this tile, this character inside the hash map, that we could use it, let's have an if in here, where if that frequency is less than or equal to 0, let's continue. Else, if we could use this character, or aka this tile, let's decrement that frequency by 1. And then let's call our function with the new frequency updated. Let's add 1. The reason we're adding 1 is to take care of these A's, B's, AA's, and AB. Because every time we're adding to this, or recalling our function recursively, we've already built a portion of the string and we want to count that. So that's why we're adding the +1. Once this terminates, we want to set it back to what it was by incrementing it by 1 again. And from here, let's just return the answer. Then finally, all we really have to do is just call this function with the frequency of tiles, or the character frequency of the tiles string. Now, if you guys are unfamiliar with backtracking, I really want to encourage you to pause the video, look at this function, at this recursive function, and see what it's doing. You guys need to be able to read this code and understand the importance of updating the frequency, then calling the function recursively, and then uh, bringing the frequency or the hash map back to the state it was. The reason we're decrementing it is because we have one less character we could use, and now we want to call this function to see how many sequences we can make with one less character. Then once that finishes, let's bring the frequency of this character back to the state it was. So now let's run the code. See if I made any errors. I didn't. Let's submit. And it gets accepted. Perfect. So like I said, backtracking is very confusing, so I really encourage you guys to look at it and try to understand what's going on in this code. Even if I were to draw it out, it would still be confusing because there's just a lot of callbacks or recursive function calls that are being made. But other than that, hopefully you guys enjoyed the video. If you did, leave a like and consider subscribing. And thank you guys for watching.